The only difference is that before we talked about it in perspective of degrees. We're going to talk about it now in perspective of radians. All right? Nothing really that different, okay? First of all, do you remember how we found arc length before?
We took the fraction of the arc measure over 360.
Okay.
And then we multiplied that by the circumference of the circle.
Okay, so to find the arc length before, we took the portion of the angle, right, from the full 360, so the full circle, and then we took multiplied by the circumference, because that gave us the portion of the circumference we're looking for. Well, what this basically was, it was pretty much, you kind of think about it, 360 is just your degree units of measurements, right? Well, what do we know? Go back to circumference. What do you know about circumference? Oh, wait. 2 pi r or pi times diameter, right? So 2 pi r or pi times diameter. Now, think about this as a substitution. If I substitute this in, do you notice anything, or can you include anything? Down.
Pi of 180
Fudge.
Wait, no, you can do that. Never mind. I'm confused. Never mind.
Late. Chastise. Bryce.
Okay. More specifically, how do those relate? Yeah.
That's 2 radians. Like 2 pi is, let's see, radians is 360.
Okay. Do you guys remember that 360 degrees is 2 radians? Or 2 pi radians, I should say, 2 pi.
So 2 pi is 180.
No. 1 pi is 180.
Okay. 2 pi is all that.
Right.
Gotcha.
So, basically, what do you know about this and this then, if I multiply?
They can cancel
They
out.
can cancel out. Because 360 and 2 pi cancel out. So really, our arc length
They get from radians.
is theta times r. And this would be in terms of radians. Okay. When theta is in radians. Yeah.
Does the radius have to be in radians?
Well, the radius isn't a measurement of an angle; it's a length. So you don't classify it as radians or degrees. Tyler,
Why do you draw your thetas like cursive O's?
like a what?
That's what the theta is.
Like a what?
Like a cursive O?
She's theta.
Why do you
Because I can't draw it perfectly. Like
Because it takes more effort to do 2 strokes.
to do what?
2 strokes.
Okay, let's critique your work.
I just
Well, no, it's just confusing because it's in the book.
No, it's not confusing. That's theta. The book is wrong. That right there.
Oh wait, can you guys the consensus? You understand that?
It bothers me, but I understand.
You draw your 6s, you start from the top to the bottom.
When you guys, Tyler, when you draw it, just draw yours a little bit more neater than mine. How's that?
It's not going to be neat, but it'll be different.
Anyway, again, arc length.
Perfect 25.
Arc length again refers to this part. Okay, it's a portion of the circumference. Okay, so do you guys remember that?
Yes.
Okay. So when we're dealing with radians, we're using theta times r. Theta times r. And that automatically kind of gives us the exact value anyway. All right. I kind of gave you guys a lot of room. I'm not exactly sure why.
We needed it. Thank you.
So down here, we're just going to do a couple basic translating, okay? Or not translating, but equations, finding the arc length. So I have a circle that's 25.6 centimeters. And we want to find the length of arcs intersected by the central angle, having each of the following measures. So the first one is 7 pi over 8 radians, okay? I want you to think about this though. 7 pi over 8. Is that closer to a quarter, a half, 3/4, or a full circle?
Full circle.
No,
Three
half.
quarters and
Half.
Oh, it's a half.
It's closer to a half, right?
Yeah.
Okay, it's almost one full pi. All right, so all we have to do for this is r times theta. When theta is in radians, it's already in radians. So I just have to do 25.6 times 7 pi over 8. You guys can use your calculators for this. We'll round to the nearest hundredth.
Should there be radians for calculator?
Yeah.
70.37. Hey.
Everyone got that?
Yeah.
I was like, so
Okay, next one. 54 degrees. Okay? What we want to do... Oh, you mean on the circle? Yeah, okay.
hey,
So, you're right.
first thing.
I want to convert. Do I multiply by 180 over pi or pi over 180?
I have 180.
I have 180.
I'm thinking piles will be pi over
3/10 pi or 3 pi over 10, however you want to reduce that. So that's a radian. So we'll plug it in.
Yeah, that's normal.
Dylan, what's the question?
Where did 0.3 pi come from?
54 over 180, that's 3/10.
Alright, so then the pi over 180 is just converting the 54 to the...
To radians, right. Because when we use r times theta, it needs to be in radians. What are we going to... Alright, questions on that?
I guess what I cast.
Alright, Erie, Pennsylvania is approximately due north of Columbia, South Carolina. The latitude of Erie is 42 degrees north, while that of Columbia is 34 degrees north. Find the north-south distance between the two cities. A note is that the radius of the Earth is 6,400 kilometers. Okay? Now, when they talk about the measurements of this, Columbia is measured from the equator, so it's north, so we go up, obviously. And that's 34 degrees. And Erie is 42 degrees. And what am I trying to find? Find the north-south, so basically find the distance between these two cities. So what am I trying to find?
8 degrees.
The 8 degrees, so from here to here, my theta, my angle is...
Oh, is this like a cross section of the Earth?
Yeah.
Dude. It's like you're looking at the Earth, right?
Like you slice it, you slice it.
That would kill so many people though.
Okay, so it's an 8 degrees portion of it, okay? The distance between the two is 8 degrees. And basically we're trying to find that arc length right here, because it's the distance between the two. I want to change it from 8 degrees to radians. Who's got that? No.
No, I just have a question.
Yeah.
So for a question like this on a test, would you give us a diagram?
I don't know.
Please do. Yes, that'd be great. I
Point one
struggle
39
just reading it.
Point what?
0.45.
0.45?
Yeah, that's what I think.
So I'm going to take 0.04 pi, I'm going to multiply it by 6,400 kilometers, because that's our radius. What do we get?
Okay, we got about 804.2477193.
800 and what?
804.
Are you sure that's right?
804.2477193 is correct.
804.247.
Yeah, let's go back.
Oh, wait.
Do 2/45, guys.
245.
245.
How does that work?
0.61.
Nice try, Janice.
It's right there.
There you go. Why is it 5 digits?
Why is it what?
Why is it 5 digits?
I can't hear you.
Why is it 5 digits?
Wait, I still got 284.5.
Did I say 2?
It's in science.
I don't think it's 245.
Wait, I don't see it.
Why what?
Why is it 5 digits? The answer is 5 digits.
Why not?
Significant digits.
I didn't say you can't get rid of
Nah, I think that you're actually.
We're running seniors hundreds.
should be
Okay, I didn't know that was the rule.
Last good man.
No, that's not right either.
It's 245.
I'm gonna settle this once and for all.
893. Oh, I got it.
But okay, but yeah, but you can't put 0.444 repeating in your calculator. And even if you fill up the entire screen, you're only putting in 4 or 6 4.
64 from 893.6.
I gotta do the
You do parentheses 4 divided by 9.
Look at this part. I'm going for
The answer is right.
I think we need a vacation.
Alright. Alright, we're
It's like you in our calculator, I got programs.
Oh, you used the last one? But I'm just saying you can't put in, like, as a 6 digit.
Oh, I don't know. What did we get here? That would be useful.
Alright. Listen. Yes. What?
Back real quick.
Right, so I'm gonna cut my calculator.
Really quick.
Right, I just told you.
Okay. Going from 8 degrees to radians, you do pi over 180, and that reduces to 2/45.
Solid. So should we more countable, not leave the fraction like that?
Yeah, it's just going to be more accurate. It'll be easier to work with. Okay. Okay. A rope is being wound around a drum with radius 0.327 meters. How much rope will be wound around the drum if the drum is rotated through an angle of, and I want to change the angle.
Oh boy. Number 2.
It's like a roundabout.
Wow.
One time I wanted to
Okay, 132.6 degrees. So basically what it means is you have this drum right here. Okay. And you start to have this rope that's getting twisted around here, okay? So this is kind of your starting point of it. We know that the radius is, and that's the 0.327. And now this drum is getting rotated 132.6 degrees. So basically we want to know how much rope.
Oh,
Here.
Okay, that wasn't a good circle.
that was actually
7.6 meters.
It wasn't.
It was ocular.
It's still.
We want to know how much is getting round around the drum once it rotates at 132 degrees. So again, this is all that arc length. I'm just trying to see that portion of that circumference.
Wait, why
So-
did you do 132.6 degrees?
I
Oh, you
just-
changed it?
I changed it.
Okay.
So, same sort of thing. I'm changing 132.6 to radians. Yeah, approximately point.
You get 221 pi over the
221 over 300.
221 pi.
You get 2.314.
What?
Alright.
No, keep
Whoa.
going.
Oh,
Basically, then this is our degrees and radians. Okay, and then we're multiplying that. And you can do this all at once in your calculator, because eventually you're just multiplying it by 0.327, which is our radius. And what do you get?
0.2475.
0.76.
Cheers.
0.757.
Cheers. Right, well, let's just go ahead.
So what are we filling in that box?
Is that right?
0.76.
No, it's not. It can't be because you put 132 multiplied 6
Henry.
180.
Henry, it's right.
Do you multiply by pi?
Oh, no, I didn't. Never mind.
No. Oh, we do.
Okay.
And this one,
Jack?
for the box, it's the 132.6 times pi over 180.
Yeah.
Are we putting anything in there?
What was that?
Are we going to put anything in there?
Oh, up here. Somebody told me it, but
Is it 2.3 or?
No, it's 0.7366. I don't know.
I don't have my calculator with me. What was the
It's like 0.7366.
736 something?
Yeah.
Okay.
0.736.
So that's really just this. This is my answer. There was 0.76 meters of rope that started winding around this drum.
That's it?
Yeah.
Yeah, but that's not
Oh, times pi?
Yeah, it's just like, but what she's doing is that she's.
Yeah, the numbers
will be 7.
What?
The numbers be 2.8.
You got that meter. Stop it.
Cheers, dude.
Okay.
You just got it.
That's figuring it out.
2.3 then it's a multiply by the radius, Drew.
We're still talking.
Tell us.
When we get the radius again, it's 0.36.
Okay. This answer, radians, is 2.3143. Da, 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 da. So, no pi.
I was doing it in terms of that's with pi. Alright, that's what you
Alright, next one.
Wait, so is the answer 0.76?
Yes.
There we go.
Alright, you need a diagram for this, okay, because I leave out some information. 2 gears, and I probably should look smaller for this one. 2 gears are adjusted so the smaller gear drives the larger one, as shown, okay? So basically what we have is we have this small gear, okay? It has a radius of 2.5. Feet. And it drives a larger gear. that has a radius of 4.8 feet. If the smaller gear rotates through an angle of 225 degrees, through how many degrees will the larger gear rotate? Now, obviously, because the size of the radiuses are different, the size of the circumferences are different, right? So the amount of area that one rotation of the smaller gear takes is different than one of the larger gears. Make sense? Okay. So what you need to do is you need to figure out how long, okay, how much of a circumference the smaller gear is actually taking. Compare that to the larger gear and then translate that back to degrees. So what you're going to do, we want to change 225 to radians because that's what we're working at with. So 225 degrees times pi over 180. That gives us what?
3.9.
Okay, so it's 5 fourths pi though, right?
Yep.
Yeah.
Okay. So it's 5 fourths pi radians. So for the small gear, so let's talk in terms of the small gear right now. Okay. The arc length is 5 fourths pi times 2.5. And that will tell me how much of the circumference this actually went through, okay, or got around. That gives us what?
9.22.
Let's keep it as 25 or 8. Okay. So there's 25 pi eighths feet around, that it went around the small circle. Now we have to kind of translate it in terms of the larger gear. Okay. This right here is the arc length for both the small and the large circle, because they go the same distance. So now we have to kind of translate that for the large gear. I know that the arc length is 25 pi over 8. I know that the radius of the large gear is 4.8. What I don't know is how many degrees or radians it actually went around. Jack?
We're not supposed to be doing this in radians. Because it asks how many degrees will be
Someone holding back.
Okay. Yes and no. Yes and no. You have to translate it in. Okay, so technically we could keep it in degrees and use the formula that we've talked about in the past, theta over 360, and then use that. What we're doing is we're just using this one in terms of radians, and then we'll translate it to degrees.
So we can translate it to radians and then back to degrees.
But, okay, no, well, but the reason why, Jack, is not really ending up being that much extra work is because this right here, are you looking?
Yeah.
This right here, we would have to be translating it in the formula anyway. There would be extra numbers in the formula. So we're just doing it before the versus later. So take the smaller group.
Guys, how about let the teacher teach?
Yeah.
Yes, bro.
Okay, you say okay, you touch the left.
Alright.
Okay, so from here, you want to divide by 4.8. Theta gives us what? 2 point what?
0.05.
2.05?
Yep.
4.5.
4.5, okay. Alright, let's change that to degrees. What do you get? 117.
Wait a minute.
Wait a minute.
Was we converted to radians and we convert back to degrees?
You can't really get that big.
What does that make sense?
Oh, because
Multiplied by 1 over 4, that's the
No. Because pi radians, 1 pi radians equals, and remember, a pi is really 3.14. So when we talk about radians, yes, you can keep it in decimal, or you can keep it as a pi if it works out. But really, I'm going to approximate it. It's 3.1415 ... radians equals 180. So it's actually less than 1 pi. Does that make sense? So it does fall. It does kind of. All right. Now we need to go up here. Like I said, I didn't leave you much room for that. Do you guys remember how you found the area of a sector? Right.
It's like angle over theta.
Oh.
Okay. So
Yes.
theta over 60 equals what though?
Yeah, area of a circle times area of a circle.
Which is what?
Times pi r squared.
Higher square. Basically the things.
Or pi times together, if you like that.
Okay. So that's what we learned before. Now, how would this be in radians though? How does this cancel or reduce?
It can be, you can take the pi and make the 360 180.
Who's that? On.
180. Theta 1 equals theta 1.
Okay.
R squared equals theta 1.
Okay.
Or times.
But it's not. Okay, this and this. Okay. Pi over 360, right? That's a portion of half. So we're going to actually use it as half. Not 1 over 180, it's half. And then it's r squared theta. So this is now our area of a sector. Half times r squared times theta. Jack.
I have a question for the answer. Would it be alright if we just did like proportions, like 2.5 over 225 equals 4.8 over x?
Say how you set the proportion again.
I just did 2.5 over 225 equals 4.8 over x, and then we just solve for
Technically, you could. All right. So here's our area. Okay, half r squared times theta. Let's just do one example of that. We have a radius of 15.2, and we have a central angle of 108. So if we talk about translating it into radians, it gives us 3/5 pi. So this is now our angle, 3/5 pi radians. We'll find our area by doing half by 15.2 and square that over 3 pi over 5. And what does the area end up being?
why did we do 3, 5, 5?
That's the radian measurement. What is it?
Oh,
That's not my calculator.
What did you guys get?
hold on, I'm about to gather that.
Alan, what did you get?
Over pi.
I didn't hear. 217 point what? 75.
217.75. 007. It's a little late. It's 007.
What?
Oh, I forgot to do that.
All right, we good?
Isn't it feet squared?
Thank you. Yes.
Why are all these calculations in radians?
Why in the radians?
Yeah.
Radians gives you. Okay. That's the translation to radians. Okay. Technically, the formulas that we used before that were in degrees. Remember in geometry in degrees? By doing the theta over 360, and it takes into the account of the circumference. Remember, we did it times the circumference. The 2 pi translates it already. So it's just a matter of, are you translating it to the radians before, or are you translating to radians within the formula?
Okay.
That's
Yeah.
the difference.
I see, it's already in radians.
Right. All right, Jack. Do it.